afternoon. My name's Ryan. Cameraman is named Izzy. The problem is there's not enough test out indicators. Problem 2, test indicators are lonely. You got to hold them. Our goal is to hold them, but we got to make something to do it. We got to make a fixture so that we can make more holders. The whole point of this is we're going to learn how to cut stuff and hold it at the same time. I don't know if you ever tried to cut something while you're holding it in your hand. It doesn't work very good. Luckily, we got CNC machines for that. Last point. Computers are smarter than we are, so we're going to use them. We're going to use them to tell us how to cut. We're going to use them to make the thing we're going to cut. And we're going to use them to make this video. All right.
So the fixture design needed to meet certain criteria and constraints. The first of which is a base size of 0.65 by 5.5 by 10 inches. The second one is it must mount to a Haas CNC mill table. It must be able to be indicated parallel to the CNC machine's axes. It must be capable of producing one finished part per loading cycle. The fixture must allow CNC program to qualify, machine datums during CNC operation 1, and locate part off of datums for CNC operation 2. Fixture must load and unload. Fixture to load and unload time must be under 1 minute. The CNC blank size is 1.25 inches by 2.5 by 3.55 inches. Clamping forces must withstand the tooling forces with minimum safety factor of 2, and we have various mighty by fixtures available, including fixture clamps, locating rails, and various locating rails, and then the dowel pin sizes available for design are listed on screen.
When designing the fixture, we had 3 primary concerns. One was how is the fixture going to be located inside the VF2 machine? 2, how is the part going to be located within the fixture, and what are the important features and datums? And 3, how will the part be clamped to the fixture? To deal with the first issue, we added an indicating band along the back of the fixture so that we could make sure that the fixture is square to the table when it's inserted into the machine. And we also added holes so that T-slot bolts could fix the fixture to the table. The second issue was how will the part be located within the fixture, and for this we used the 3-2-1 rule. Our datum A was the back of the part will touch the top surface of the fixture with 3 points of contact. Our datum B is the back wall of the part will be against a mighty bite rail with 2 points of contact, and datum C was 1 point of contact against a dowel pin. We also calculated tangential tooling forces and only found about 4 pounds per tooth, which is a small force, but we added mighty bite clamps to ensure that the part could not be thrown during machining. This is the final fixture model that we came up with for our design. As you can see, it's 2 very similar operations, Op 1 and Op 2, labeled on the fixture. The difference being the depth of the pockets, as you can kind of see in these 2. Op 2, you can obviously grab more of the part using the clamps, and the rail also has a little bit larger contact area. Jumping into the machining operations, the key ones of importance were again the rails, the clamp pockets, the dowel pin sizes, the indicating band, as well as the slots we cut out for the T-slot bolts to clamp the fixture to the table. So quickly show the toolpaths we came up with. This is trimming and applying a radius to the fixture so that there's no sharp edges, won't cut anybody when they're installing or running parts. Here we're cutting the T-slot reliefs. There's another pass just above that. for the larger pocket. And then we've got our rail passes, which are slightly oversized to ensure that the rails will fit inside of the pockets. And then we've got our pockets for the Mighty Bite clamps. And through holes are also drilled and tapped so that they can be screwed in. And then we have our dowel pin holes, which are drilled and then reamed to ensure that the dowel pins can be inserted into the fixture.
Here's a test out indicator fixture. A quick visual qualitative inspection presented no issues that might affect op1 or op2, and it seemed to fall inside the design criteria as well. So from here we moved on to testing the fixture with stock aluminum to be cut into test out indicator holders.
Chris, yeah, here. Oh, another $160 in yeah. Alright. I buy good ones. So that's why I get all. We can't go that fast.
And then
Send. giving. And then
Alright, so face your.
this is the final product. As you can see, it came out pretty cleanly. The cavity here is where the dial indicator will sit, and it's got 4 holes to allow it to secure through the back. The only problem we had with this part was one small nick there from a chamfering tool. This is due to an incorrect offset. The program had to be paused in the middle. We were able to resolve this for our next part that we ran, which came out perfectly.
After testing our fixture, it was able to machine 2 instances of op1 and op2 for our test dial indicator holders with no issues. As you can see, it is holding op2 successfully here with no toolpath interference issues. Our design was able to meet all the criteria necessary, and we were confident it would, and being able to machine 2 test dial indicator holders proves this. So as we explained before, the world is suffering from a lack of test dial indicator holders, and it's up to Ryan and I to be able to create a fixture to be able to machine these. So we used SolidWorks and HSMWorks to be able to create the design, and then we used Haas VF2 CNC machine to machine them, and we did it. The world will no longer suffer from a shortage of test dial indicator holders. Overall, I think Ryan and I did a pretty good job with this. Op1 and Op2 are essentially mirror images of one another, so when there's an issue with one, we were able to change it on the other one easily. Since we were able to create a successful test dial indicator holder, we see no reason to change our design, other than possibly having multiple operations on a single fixture. I think we did a pretty good job with this.